Hello students, in our last lecture we have already studied about meter out circuit, and now we are moving forward to our next circuit, which is regenerative circuit. Okay, as the name symbolizes, it is actually a regenerative circuit, means it is going to regenerate some kind of a flow. So we are going to learn something about this circuit. In the construction we are having a pump. Okay, then this pressure regulator, this filter, this is a complete drain, this is 4/3. Okay, I'm having 4 ports and 3 sections, solenoid operated, this is solenoid operated, DCV, and this is 2/2 double acting cylinder. Then the first connection in our first section, it is a normal working section in which the fluid will go inside, and from here the fluid will come outside. In the first section and second section the normal working is there, but in the third section, which is in the middle of the DCV, we are having a supply which is going into the cylinder directly, and from the other side of the cylinder we are making an exit, and which is actually coming to the DCV, but it is not going below the DCV. It is transferring to main supply line, main input line, so that the flow gets increased, okay, up to a particular limit. Okay, suppose I am having a flow from here is 5, 2 is a written unit, 2 unit is a written flow, and 5 units is the inward flow. So because of this 2, the 5 unit gets added with the 2, and because of which 7 units is supplied into the cylinder. Okay, so this is the basic working on the regenerative circuit. Okay, so we will move further to our next circuit, which is bidirectional. Okay, one more circuit is there, bleed-off circuit. So let's study this. Bleed-off circuit is having a construction as such: double acting cylinder, 4/2 DCV. Okay, and this is spring operated, partial spring operated, partial solenoid. Then we are having a pump, pressure regulator or pressure relief, then a variable flow control valve, and a filter. This is a complete construction. From the supply or the flow goes into the pump and then into the DCV, and DCV allows the flow to go into to get filled into the double acting cylinder. Then as the fluid gets inside the double acting cylinder, the piston will move in the direction from left hand side to the right hand side, and because of which the fluid in the B section comes out, and then it gets returned to the drain. Okay, so this is the working of the bleed off. The difference between the bleed off and the other circuits, the meter in, meter out circuit, we have already discussed about the disadvantage of the meter in and meter out circuit. It is actually having a disadvantage that the DCV of the system in meter in and meter out circuit gets damaged after a certain period of time. Okay, so to compensate with that disadvantage, we are making an advanced circuit which is known as bleed-off circuit. So bleed-off circuit is actually an advancement of the meter in and meter out circuit. So because of this, we are using a flow control valve in the middle of this. Okay, we are not having a sequence over here. We are using flow control valve over here. Okay, so because of which we can easily supply the flow inside and then return to the drain. Because of which the damage done to the DCV has been removed or completely eliminated. Okay, and when I am talking about the second, this is the first section and this is the second section, and when I am talking about the second section supply, the fluid will go inside, crossover, and move inside the double acting cylinder from port B. And when it is moving inside, the piston will move from right hand side to the left hand side, because of which the fluid which is inside the cylinder comes out from port A, then to the DCV, crossover and inside the drain. Okay, this is the normal working of the bleed off circuit. We will move to our bidirectional hydraulic motor. Bidirectional hydraulic motor is actually a motor in which we are using motors. Okay, it is having a motor. So bidirectional means it can rotate in the clockwise and in the anti-clockwise direction. Because of this we are telling this circuit as a bidirectional motor circuit. Okay, and we are having a construction of this motor. This is a combination of or a pair of flow control valve and a check valve. We are having two of it. Then we are having a 4x3 DCV. Okay, 4x3 DCV, semi floating type. Then pressure relief valve, filter, pump and drain. This is the position number 1, and we are going to start with our position number 1. The flow from the pump goes inside the flow control valve and the check valve, and from there to the bidirectional pump. As the fluid is coming from left hand side and moving to right hand side, so the flow will be like this, and because of which the bidirectional motor will rotate in clockwise direction. As the direction control valve changes its section from first section to the second section, the fluid starts moving from B to A, because of which the bidirectional motor will rotate in anti-clockwise direction. Okay, anti-clockwise direction, and due to the anti-clockwise direction of the motor, it will start moving downwards, crossover in the DCV, and again comes to drain. This is the second position. Okay, this is the first position in which the bidirectional motor rotates in a clockwise direction, while in this section, in the second section, in the second position, the motor rotates in the anti-clockwise direction. Now, if I am talking about a third position, which is a middle section of the DCV, so in this the fluid will go up, get inside DCV, but it will not allow the fluid to move forward or advance to the motor section. It will just make sure that fluid gets returned to the drain directly without going further. Okay, which actually avoids the motion of the bidirectional valve. Okay, so this is a complete working of bidirectional hydraulic motor. Linear actuators. Linear actuator is actually synchronization of two complete parallel cylinders, using which we can easily lift a mechanism, or even we can easily lift both the cylinders together. Okay, suppose I am having a floating chamber over here. So to lift the chamber or floating floor, or to lift the floor, we are required to move the piston synchronously together. Okay, so to do this we are using this circuit, linear actuators. We are having a pump over here, pressure relief valve, then filter, 4x3 DCV solenoid operated, two pistons are over here, and this is a coupling, or we can say a weight extra added. Then see, the piston will move in straight into the DCV, the flow will move straight into a DCV passing through a pump, and then it will get split into two types. First, it will move in the first piston with the inlet port of A1, then from here it will move the second part of the stream into the second piston from the port A2. Similarly, we are having another flow because we are having a double acting pistons. So the second port will have an exit from B1 and will move down, get it added another stream from second piston as B2, and then it will move into the drain. So together we are actually dividing the two streams, single stream into two streams in both the lines. So because of the moving forward of the fluid gets split into two parts and it will lift the piston upside. But when I am talking about the second position, so because of the second position, the fluid will move in the reverse direction and it will go into B port and it will lower the piston synchronously. Okay, means together. So this is the complete advantage of the working of the linear actuators. See, this is the second working. It will get crossed over and move into the B section of both the cylinders, and A section will come outside, gets added, crossover, and then into the drain. This is the complete working of the cylinders. Now I am talking about the hydraulic forward strut machine. Okay, this is actually a shaper machine. So here, this is a pump. The flow will move inside. This is one kind of DCV. It allows the flow to move inside. Because of this movement, the fluid gets filled in this section, and hence the ram moves in the backward direction from right hand side to the left hand side, because of which the cutting stroke will take place. Okay. So similarly it will work in the forward stroke. So this is a return stroke in which the fluid is moving inside. See, this is moving inside, because of which the fluid piston ram will move in the forward direction from left hand side to right hand side, and because of which the complete section gets moved forward, and hence the tool cuts the part. Okay. This is a hydraulic grinder or a milling machine, you can say. Thank you. We will stop over here, and hence we complete our 5th chapter hereafter. Okay. Thank you.